Happy Pi Day? So let's have a go at question 2. So find the sum to infinity of the geometric series. The first term is pi squared over 2, second term pi squared over 2, subtract pi cubed over 4, and then the third term is pi squared over 2, subtract pi third over 2, pi cubed over 2 plus pi to the power 4 over 8, etc., etc. So we need to find the sum to infinity of this geometric series. So we just remind ourselves of the formula to do that. So the sum to infinity is a over 1 minus r. So a is the first term of the sequence. So a would be pi squared over 2. And the common ratio is r. So that's what we multiply by each term. So an easy way to find common ratio is to do a term divided by the previous term. So that should be the same for every set of terms in the sequence. So if we take the second term, which is pi squared over 2, subtract pi cubed over 4, and we divide that by the first term, then this should give us the common ratio. Now you could have done the third term divided by the second term, but that looks a bit more complicated. That will give you the same thing. We can assume that this question is correct. So what we can actually do to simplify this, if you factorize the top, you can actually see that you could take out a pi squared over 2. And so in the top you'd have 1 minus pi over 2 divided by pi squared over 2, and so these will cancel out, and so r will simply be 1 minus pi over 2. Now we have this rule that the sequence will only have a sum to infinity if it converges, and that will only happen if the modulus of r is less than 1, or r is between 1 and negative 1. So this is the validity when the sequence will converge, when we can have a sum to infinity. So pi is roughly 3. So 3 divided by 2 is about 1.5. So we can see that 1 subtract 1.5. It's going to be about negative 0.5, negative 0.6. So it does work. This sequence will converge. So we found now our a, and now we've got our r, which is 1 subtract pi over 2. Okay, so we're going to put a and r into the sum. So the sum to infinity is a, so that'll go on top. So pi squared divided by 2 divided by 1 subtract r, so 1 minus pi over 2, so I put all these in brackets. So 1 subtract 1, it will cancel out to 0, and then subtract negative pi over 2 will give us pi over 2, so we're going to get pi squared over 2 divided by pi over 2. That would be the sum to infinity. So what we could do is we could use the idea, if you division by a fraction, so to cancel out, you can multiply by the reciprocal of it. So we could say that this is pi squared over 2 times 2 over pi. So you can see the 2's will cancel out, one of the pi's, and so the sum to infinity of the sequence, shock horror, is pi. What a fantastic result for Pi Day. All right, that's question 2 done. See if you can ever go at question 3.